Day 315 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 260, single number 3. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Question says, given an integer array nums in which exactly two elements appear only once and all the other elements appear exactly twice, find the two elements that appear only once. You can return the answer in any order. You must write an algorithm that runs in linear runtime complexity and uses only constant extra space. All right, y'all. So yeah, that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, 1, 3, 2, and 5. The output is 3 and 5. Explanation says 5 and 3 is also a valid answer. So 3 and 5 or 5 and 3, because it says you can return the answer in any order, is a valid answer. All we're doing is we're going through this array and we're finding the elements that only appear once. In this case, you can see that 3 appears once, 5 appears once. So those are the answers, or those are the two elements we return. All of the other elements will appear twice. Boom. So let's look at example 2 in case they try to throw some tricks our way where there's only elements that appear once and one of them is negative. So in example 2, we have the input nums equals an array of integers -1 and 0. The output is still -1 and 0. Even though there's no other elements in it, these elements still only appear once, so we're going to return both of them, and once again they can be in any order. Example 3, same thing, nums equals an array of integers 0 and 1. Output is 1, 0. Once again, that could be in any order. It could be 0 and 1 or 1 and 0. But as you can see, both of these elements only appear once, so we are going to make sure that we return those elements. Now that we understand the question, y'all, let's get into the fun part, the actual solution, right? And for this solution, we're going to use some bit manipulation. So I hope you're excited about that. So we're going to be using the XOR, exclusive OR operation. So first, let's go over what that is, right? So first thing, what the XOR operation does is it's going to compare the two values in binary. So for example, say we have 5 in binary, which would be 1, 0, 0. That's 5 in binary, excuse me, 0, 1, 0, 1. And then say we have 3 in binary, which would be 0, 0, 1, 1, right? We would compare these operators where if the bits are the same, then the result will be 0. If the bits are different, then the result will be 1. So in this case, we do it like this, compare them like this. We'll start right here. So this is a 1 and a 1. So since they're the same, it'd be a 0 right here. Then this is a 0 and 1. Since they're different, that'd be a 1. And since these two, same thing, these two right here, they're different. So that would be a 1 as well. My bad. Clean that up for y'all. And then once again, these right here are the same. 0, 0, 0, 0 are the same, so we could put a 0 right here. So that's how the this operation works. The bitwise OR operation looks like this. Where is it? Right here. So when you see this and dealing with bit manipulation, that's what this is doing. That's what it's doing right here. It's just comparing each bit, and if they're the same, once again they turn to 0. If they're different, they turn to 1. So now that we understand what that is doing, let's get into the actual code and start coding, right? So the first thing we need to do is we're going to need to create some variables to store the XOR of the two, or the exclusive OR of the two unique numbers, excuse me. So in order to do that, we could just declare a variable. We call XOR, set that equal to 0. Then we'll say comma, which is another variable, set that equal to 0. Then we'll say comma, b for another variable, and we'll set that equal to 0 as well. Now we're going to perform this XOR on all of the all of the elements in the array, and since every number appears twice except for two unique numbers, all duplicate numbers will cancel each other out, leaving only the unique numbers that we're looking for. So in order to do that, we could come right here, we could say for n nums, then we're going to open up the brackets, we could say XOR, then we could do the XOR, then we do the XOR operator equals, then we'll say n. And what this does, right, so this is just saying, like, this would just say, so let's say this is just an example, y'all, sorry y'all, so let's comment this out. We can say, so this, boom, boom, is equal to, that's the same thing as if we said this right here, right? If we said, so this is the same thing. This right here is the same thing as this, or excuse me, as this. So we just wrote it like this just to, just easier, right? Easier syntax to write. But once again, this and this, same thing. So boom. Let's keep going. Now we need to find a bit that is set to 1 in the XOR to differentiate the two unique numbers. So in order to do that, we'll come right here. Sorry, y'all. Let's clean this up for y'all. We'll come right here, and first we're going to declare a variable. Call that diff bit, and we could just set that equal to 1. Then we come underneath that, we could say while XOR and diff bit equal sign 0. We're going to open up the brackets, and we're going to left shift diff bit until we find a bit that is set in XOR. So in order to do that, we could just say diff bit equals diff bit 2 less than signs 1. Boom. Then we're not done yet. We're not done yet, y'all, because we still need to partition the numbers into two groups based on the found differentiating bit. So in order to do that, we're going to come right here. We're going to say for n nums. We're going to open up the brackets. We're going to say if diff bit and one and sign n equals 0. We're going to open up the brackets. And if the bit is not set in n, then XOR into group A. So we'll just say A equals A XOR n. Boom. Then we'll do the same thing or the XOR exclusive operator. Boom. Then we're going to do the same thing for B. So we're just going to say else, open up the brackets. We're going to say B equals B exclusive OR operator n, just like that. Boom. And now we just need to return the two unique elements. So we could come right here and we'll say return, open up the square brackets, A, comma, B, just like that. Now let's run this. Make sure it runs like it's supposed to, y'all. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users with Swift. Not too bad at all. Those are the numbers I like to see. And with that being said, make sure y'all get one more look at the code. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.